Remainder theorem. Assume that fx be the polynomial function. Fx be the polynomial function. Now we are going to divide this polynomial by x minus simple a. S minus simple a. Simple a be the real number, right? S minus a may be equal s minus 1, s minus 2, right? Simple a is a real constant. Let qx be the quotient. How to write the remainder? We know degree of divisor is 1. Degree of divisor is 1. Degree of divisor is 1. Always degree of remainder should be less than degree of divisor. Degree of divisor is 1. Therefore, degree of remainder is equal to 0. Degree of remainder should be 0. If degree is 0, how to write the polynomial? Degree 0 means polynomial function is equal to a real constant, right? Remainder should be real constant. Let r be the remainder, right? Actually r is a real constant. Degree of r is 0 because degree of divisor is 1. Degree of remainder should be 0. We can write capital R as a remainder. According to divisional algorithm. According to divisional algorithm, how to write the equation consists in dividend, divisor, quotient and remainder. Divisional algorithm is dividend fx equal divisor into quotient. Divisor x minus a, quotient qx plus remainder capital R. Fx equal x minus a into qx plus remainder capital R. Substitute x equals simple a. Substitute x equals simple a. Now fx become fa. Fa equal a minus a, qx become qa plus capital R. Fa equal, we don't know the value of qa. Actually we don't know the value of qa, but a minus a is 0. 0 multiplied by qa is equal to 0. Answer of this product is 0 plus r. Therefore, remainder r is equal to fa. Remainder r is equal to fa. This is the proof of remainder theorem, right? Now write the definition of remainder theorem. Write down the definition of remainder theorem. Let fx be the polynomial function of simple x. Let fx be the polynomial function of simple x. If polynomial fx is divided by x minus a, if polynomial fx is divided by x minus a, then remainder is fa. The remainder is fa, right? Then write down the proof of remainder theorem.